Alright, give me like 2 minutes. I want to just get water.
Unmute my mic. I'm gonna mute the desktop audio, so now I should be able to play my music. And I don't have to worry about anyone hearing it. Dun, 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 dun. So now let me... Awesome. I gotta pace myself for this one since Nick is not here. Do I have my water bottle? I do. No, where's the other one? Oh, my good stopwatch. My brother's been out. Huh? Oh, I moved something, didn't I? What did I just do? Did anything fall? No? It's safe? Okay. Let me see what this was like. That one's okay. I like this one. Okay.
So I think I'm gonna get humble.
You're gonna get humble?
Because It's been too many months of like really good shit, and I don't know why I don't have it.
Humble Monthly is what you're talking
Yes.
about?
Yep.
I mean, go for it if you want it. I don't care about it. I'm the one who doesn't.
So you don't care about it after you had it for like 10 years.
I don't get Humble Monthly. I get Humble
Not anymore.
Bundles.
Oh. Oh, so all those things were just like from actual purchases instead of like things you just get automatically?
Yeah. Everything I've ever gotten from Humble Bundle has been bundles. I've never used their monthly.
Should've
But I've
just
been
took
having Humble
Twitch.
Bundle for a very long time. I've had it since. Let me see how long it's been. You have to understand how long it's been since I fucking had Humble. I used to be hardcore gamer, dude.
I see.
There was a time when Edward didn't program it. All he did was draw and play games.
Oh. Oh. Alright, I lied. I was playing Rocket League and I just won. And I'm done. And I'm exiting.
How long has it been since I've had Humble? I've had it since 2011.
Alright, before we actually begin, let me buy Vegas.
Okay.
I was trying
Oh,
to do
they
it
have
on my
a
phone.
artificial intelligence bundle. Ooh.
Yeah, they do. Pretty interesting.
Let me see if they're any good. Well, I can probably
Deep
find this on
learning,
the eye.
Dude, if we're gonna do fucking deep learning for the, if only they had a book for algorithmic trading. There it is. They have it. $8.
Financial technology. They do.
There it is.
The Bitcoin Big Bang, all this other shit. Is there an algorithmic Big book in here?
Oh, dude, for $15, you're getting so much.
Probably
Maybe
on
add
the
some
eye.
CV
Watch it be on the eye. Watch this thing be on the eye. Let me go get it out. Where's the eye? Let me see if I can find this shit. Oh my fucking god, I swear if they have it. Humble Bundle. Where are those? Books? Yeah, it would be under books. Humble Bundle. Definitely can't make this this TBF public now. Because I'm fucking searching on a goddamn
What
archive.
you are? Oh my god, yeah.
I wanted to see.
Ruined.
Bankruption. Let me see if it has bankruption.
Demonetized.
Blockchain. Do you have blockchain on here?
25.
Oh, I can't find it. Fuck. Maybe it's a different. It's too new of a bundle, maybe. No, it's not under cybersecurity either.
What? I'm getting this under Edward Jay-Z. I'm logged in as you.
No! Don't do that!
I know. Just changed it. And now I'm in mine. Fuck. For my email. Verified. Alright, it's me. And I want this. What?
What you want to do with the hamburger meat?
I don't know. It's the only thing.
Make a patty out of it.
Make a patty. I had no plans. Alright. Maybe I should share my screen just cause.
Yeah, definitely do. I'm gonna have it on the other screen since it's only you. Oh, don't show me your purchase.
I don't know.
I don't give a shit. I'm not putting it. I didn't put it on the
I
live
just-
stream.
I didn't eat too long ago. I ate not too long ago is what I'm trying to say.
You're gonna have to eat again.
Alright.
Is everything there?
You're getting this bundle. Yes. Pay with PayPal. Pay with Amazon?
Yeah, I've done that before. It's the same thing. I think
I don't know,
I don't know if
had
Amazon
it.
charges you for it though. I don't know if they add a surcharge.
Those motherfuckers. Adding surcharges. Damn. Is this blocking it or something? Don't block combo bundle. We're safe here. God damn it. Trying to play with PayPal and it's just acting like I didn't click on anything.
Amazon's like, we're gonna own PayPal soon. Just buy it.
Oh no, we got it. We did it.
Okay. Do I need anything else? I don't think so. Let me see the notes. I gotta tell about the corrections or the changes I made. I only made one change.
Are you gonna get the AI one?
The what?
Are you gonna get the AI one?
I might. I don't know yet. I probably will, to be honest. I like having reference books like those, so.
It's pretty hard to pass up for 15.
Yeah, exactly.
It's so hard to say no.
I have such a giant book backlog, not from the book link collection, but from the fucking ones I already bought that I need to read. Fuck. I still need a buffer 4 more books.
Alright, opening Visual Studio. Get ready. And actually getting water now. How dare you? Yeah. Oh, that's a big Betty.
Well, I realize we don't have to do that.
Oh. We need your ramen, Edward.
Oh, tomorrow. I'll bring
He's gonna bring
2
Peter
packets tomorrow, 3 packets tomorrow, so we can all eat it there. Have 3 eggs. I don't know what else goes with road ramen, but find something, cause it's $3. Keep it in mind. It's not gonna be amazing unless you add some stuff to it.
Leave him to it.
Just keep it sealed. I think all this stuff, I don't know what you want.
Oh, just cause, you know, plastic bag. We have zips. Alright. Alright, ready to go.
Okay, ready? Starting the stopwatch. Let's get started. First of corrections. So the only thing I did was I refactored this to this name. So you might want to check yours. It was the one that converted it to microseconds.
Wait, let me see. The stream is like just starting. Okay, let me see. It says this. Oh, I didn't. Yeah, I have underscore offset on mine.
I just said tick to microseconds. I just changed it to that. I don't know why. I think it might have made more sense at the time. Tick to microseconds. That's all. Camel case, upper camel case. So starting with upper, but yeah, because it's a macro. All right, and I think we're back to action. So yeah, last thing we did was we implemented delta time. So if you run it, just as a review, we get this loop time in seconds. Now, this is great and all, but a game can't have an infinite scrolling thing like this. We need to have a proper sized refresh where it just does one line and then it refreshes the console at least. But eventually we're gonna get to a text render. But for now, we can start implementing that system. So the way we're gonna do this is we have to implement something that's called a routine for clearing the console. I'm pretty sure that's where, let me just make sure the order that I wanted to do this, because this is going to be nasty. Nasty. So I didn't specify an order, so I'm just going to go by what I deem would be the easiest route to doing this. Looking through this. So yeah, before we upgrade our timing system, we'll start the console system. So let's look for where we do this is the core loop prep section. So we're gonna name this section the timing stuff for now. Yeah, we'll just call it timing stuff. And we're gonna name a new section here. And this is gonna be called console setup. So to do what we want, which is basically a clear console, so we completely removes all the text from console, at least from what we see. We need to use, again, Microsoft's platform, because this is Microsoft's console. So, because if you you could clear console in a really shitty way by just pushing a bunch of blank characters with printf a certain way, but that's not efficient. It's a pretty terrible way of doing things, so we're gonna just go the non-portable route like we did with the timing for better features and just a better overall engine from it early on. So the way we're gonna do this is, let me go look for there's a way to go look for the documentation. So last time I already had the documentation and I already had the order. This time I'm gonna try to slow things down and show you the process of doing so. This will keep the stream I had the countdown, but it'll just keep things more paced, I guess. And I need to show you I need to show Nick the way you find these things. So naturally it's going to be on MSDN. So we're going to go on msdn.microsoft.com, which is the area where you can find documentation. We're going to go to APIs and reference right here. And we're going to look for C++. So that's going to be, I don't know why this looks so different. Hold on a second. MSVC. Let me see if I can find. This is so weird. Just type in Visual C++ documentation, and that should get us straight to what I want, which is this. I don't know. Docs.microsoft.com. Sorry. So we want the Visual C++ docs. We're going to go to languages and libraries, and it's going to be the standard C++ language and libraries. And what we're looking for is essentially the functionality to clear console. Now, if you try to look for this thing like this, you'll come across these search category things, and they'll go for 5 pages, it says. If you go to the last page, nothing's related. Oh, it goes for longer. So it actually is more than that. These are all the routines for reading and writing to console. But that's not what we want. We want something that's clear to what we want. So far we're coming up short, which you will. Pretty sure come up short. So you're not going to really find easily what you want from here. So then you're going to go and resort to Google. So we're going to go clear console, C++ Visual Studio. Because because it's the visuals. It's part of the. This thing is part of Visual Studio's thing that it's doing. It's Windows is console, but Visual Studio is using it for the debug and stuff like that. So it's probably related to it. That's why I decided to search it in the context. So then if you do that, the first thing you'll see is this MathBits site, which I don't remember if it had a good explanation. So the first thing you'll see is the System CLS thing, which will work, but you should always grab a second opinion, and you'll see why you should with this one. So let's look on Stack Overflow from 2011. So if we go through here, and we go to here, for example, that looks too much, so let's try finding something better. This is our first real hint, so we're going to keep this, put it on another tab, and let's keep looking around, because that looks like that looks a little bit off from what we want. And you notice all these dates are old, so you want to avoid that, because what happens is programming APIs get updated constantly. So you want to find the latest, and you want to make sure you avoid anything with Linux, because remember, we're on Windows. Eventually, we get to what we wanted. So instead of clear console, we should have typed clearing the screen. Oh well. So the first method they show is the System CLS. Now, I can't believe they're not telling you what's wrong with this, but I'll explain in a moment why you should never do that. Then you have this thing right here. Example 2 is actually the right way of doing it. Now let me show you why you don't want to do System CLS. See if I can find what I found earlier. It's called Why System is Evil. That's what I'm looking for. It's just something you had to have found. This thing basically explains why you should never use this command. So I'm gonna put it. It's just things you have to like learn. This is one of the unfortunate things. This is why you always want to go for portability, because when you look if you find the old way of doing it, and you don't realize there's a better way nowadays, or a system-specific way of doing things that might be old, and you have just no context of this kind of cancer, then you would have avoided it completely by just staying with the latest standard and latest portability. But unfortunately, portability to me is like a farce. Even Java is not as portable as people like to make it look. Because here's the thing.
Hello.
Hi.
So,
Who's this?
not much.
Oh, Matt.
Me? Matt.
So, no problem. So, the problem with portability is being a farce. I mean, like, why it is because even with Java, the standard feature set that they give you is usually not enough if you're doing for real project to get what you want done without starting to use someone else's library. That's something someone else has made, either a company or something else. And most likely that company would have never fucking bothered to make that library available on a different platform. They may have done some bullshit hackery with the JVM assembly to make it use some C code, for example, and then hacked it in there so that it would only work on Windows. So that's the sad reality of it. Is it good to use one of those though? And is it more likely to have more of a feature set of code that's portable for you, so there's less of a chance of that happening? Yeah. Way better chance of using a bunch of C# code that you don't have to fucking find some platform specific bullshit for example, than you would ever get close to having with C. But don't ever think that code is always going to be truly portable. That's mostly for Nick. So I put the C++ article on the TBF v2. Good, I did. So now let's ignore this garbage and this garbage. And this is what I'm going to be basically translating for you, because this is using procedural programming, but we're not there yet. So I'm going to translate this functionality into what we're using. But if you wanted to at least see what I'm using, it's from here. And I posted in TBFV2. So now let's get started on the real coding. So for console stuff, we're going to need to make a few addresses to a bunch of things to make this work right. The first address we need is an address to something that's called a handle. Now, if you're wondering what a handle is, you can get a hint by that that little highlight. What happens when you highlight over it? It says it's the type def to void star handle. If you peek on it, you'll get more info, which you might be able to get some more hints on what it is for from the stuff around it. What it essentially is a pointer or address to the handler of something. In this case, it's the console handler. And that's why we're going to be naming this address the console handle. And you can tell what void star is if you don't remember, by looking up here to our memory related macros where we named address type star. So if we're doing void star, it means literally no type specific data address. So that's what exactly where we're pointing to. So that's our first address. The second address we're going to need is called a D word. And it's going to be holding what's called characters written. Because we're going to be writing and essentially to clear console, the way you do it is you fill the buffer with characters. So even if we did it, even if we try to avoid the printf method, we would still have to clear console by just filling it with characters. But at least this way, it's going to be efficient, or at least efficient as we can be with console. So if you look at the D word, you find out D word is an unsigned long, which basically means an unsigned 32-bit integer. Yeah, so that's what a D word is in Microsoft terms. Next thing we're going to need is an address to a coordinate, or chord, and it's going to be the screen coordinates. And what screen coordinates is going to hold for us is the home for the cursor. So essentially what's going to happen is when we clear the console and we fill it with characters, we want to force the cursor, or where we're going to be writing printing to next on the console, to be back at the home place, which would be 0, 0. But we'll fill that out later after we give it the proper allocation address for where we're going to be storing that. If you peek at the definition, you'll see it's a structure. Again, I didn't really want to go into structures, but just know that there's two components that make up this coordinate, and it's going to be an X and a Y because it's a 2D coordinate, and they're made of shorts. And what a short is, if you preview that, is literally a short, and that's shorthand for signed short integer, which is a 16. I think it's a 16-bit integer. Yeah. So we're going to be, after that, we get to our fourth address, and this one's a little bit long. This thing is called the clear screen. Let me see if I can find it, because I made it a macro already in my other example. I need to define that macro with you. If I can find it, that is. Where did I put it? Because I have it closed, I can't find it easily. Hold on a second, I'll be right there. Oh, there it is. It's called console screen buffer info. We're going to abbreviate it in here as CSBI. So we're going to make a new macro under our data type macros, which is all the way up here. And we're going to define CSBI as console underscore screen, all caps, buffer info. And then when you go back down, we can finish off this address, and it's going to be called CSBI instance, because that's all it is. It's a console screen buffer info instance that we're going to be referencing.
What does CSBI stand for?
Console screen buffer info. And it's all caps with underscores between each word. I'll scroll up in the video just in case that was too fast, but Nick can pause it and rewind. So he does have that advantage. Next is going to be the address to another D word. This address is going to be for the console size. So this is basically going to get keep a reference to the console size that we're going to be filling in with characters, space characters, or whatever we're going to be filling it in with. I think it's space characters. So when we do the fill, we want to store the result to make sure it succeeded, or we might want to exit the routine early. So in order to do that, we need to save the boolean, and we're going to call the first boolean that we're going to be doing this check with. It's going to be called fill result. And another boolean for another thing we're going to be checking is properly set, in case it isn't, so that we can set the attributes, and that's called attribute result. If you don't know what I mean by that, because it's kind of off-putting to keep track of what addresses we're putting here and here until we do the actual functionality. Wait till then. And the last address we'll need to do just for this console routine, I'll call this, not console stuff, clear console routine is what we're doing. So we might as well start calling it that. So this is like the prep for the routine, so I haven't made a label yet. And the last thing is address to a unsigned integer, which I don't think we've made yet. So let's make a nice uint macro, which is going to be under data types, right before the int64, after int64, because it's going to be the unsigned. So define uint, and that's going to be unsigned integer, like that. And we can go back down and use it. So this is going to be the return routes. So when you make a routine, which you're going to learn right now, you may want to have multiple different areas of your call out routine, but you want to make sure that it can return to that wherever that last place it was, and that might be multiple different routes back. So you have to store the number of routes as like a table of values that you want to do, and we're going to store them as macro values. And depending on where it is, so there's going to be one that's going to happen like around the update render area, and that's going to be basically called, when we get to it, like return to core engine, something like that. And basically that's what this number is going to store, which return route it needs to do, and I'm going to show you how you assign it and stuff like that. So now we have 1 2 3 4 5 6 7 8 different data types that we now have to allocate in our memory block here. So let's make a new definition for a bunch of memory allocations. So we're going to call this the size of clear console, or console data. Console data is better.
Dude, oh, yours does that too. Okay.
Yeah, it does. It does.
I fucking hate that defined presentation.
Yeah, it's because of, you're not so technically supposed to put macros wherever you want. You usually only put macros in the top. Yeah, and you're not supposed to put it in within functions, and if you do, it's supposed to look really ugly because, again, it's not something you use in C or C++. In fact, all of C and C++, well, C++'s functionality, not C's, try to basically add functionality so that you don't have to use macros. That's the whole point of templates. So you don't have to make a macro for a template, because that's what you have to do in C.
Gotcha.
Nick, basically what I just said, if you're watching, is in C++ there's a bunch of generic stuff to make what's called generic functionality that would normally require some crazy ass macros to do, but they have it supported by the syntax of the code itself and its keywords. so you don't have to go there, and it makes it easier to debug and figure out what's going wrong. So just stuff C++ lets you do. Anyways, back to this. We need to start putting in all this data. Now, you notice how far away it is from this thing. In order for you to do get this right, notice in 2019 there's this little thing right here in the top right corner. I'm pretty sure. Do you have this, Hazar?
Yep.
Okay. If you so what you're gonna basically do is drag that down, and you're gonna get two of the same window, but now you can put in different perspectives of the document. Essentially, think of this as like you just opened a wormhole to different parts of the document, so you can watch them at the same time, I guess. So now we can look at size of data console, and we can look at all the addresses we had to get the size of. So we got first off, let's do it in order. So we're just gonna do size of handle. Then we're gonna add size of a. Remember not to allocate for an address, because we want to allocate for the stuff the address is going to point to. So we're gonna do size of dword plus size of coordinate plus size of CSBI plus size of dword again. Plus, there's two booleans, so let's do size of boolean times 2, and then lastly size of a uint. And that should take care of the entire amount of memory that this console routine is going to need. So from there, you're going to just add it to your memory block right here. So size of console data right there. And that should take care of things, so long as you spell it right, which I didn't. There we go. Now that's good. And of course, you want to make no, we don't have to do that. We don't have to worry about that yet. So we have to assign them the addresses next. So let me go to the addresses area. So we can close this little wormhole thing there, and we can go back to here only. And now I'm going to be doing the address assignment. So remember that the last address we assigned here was to delta time, and that was loop time elapsed +1. So now in order to get the where on the memory block is going to be the location of where the handle data is going to be, you need to put console handle equals delta time +1, and that will just basically do the correction, the offset correction it needs. And then you remember you have to cast this to what it is, so it's going to be an address handle for that. Now we rinse and repeat for everything the way literally with a +1 for the last thing you addressed. So this is just the really tedious part. But what this is going to do, the reason I'm going this route with the memory block is it's going to slowly ingrain the patterns of a structure that took me a while that everyone tries to make as ambiguous as, or at least the way they explain it, even in like a .NET exposition on something like GDC or something else. They always explain the structure that all these programming languages have, that they do in the background for you, is something that helps you, but they never truly explain what it is in an easy way. But by doing this really manual way of setting up this memory block, you basically have made it. And I'll go fully into what it is later, but just so that you know, what we have made essentially is a stack. And that's why every single address we do afterwards is just +1 from the last address. So this is size of type. So it's going to be screen coordinates equals address chord Characters written +1. CSBI. Okay, and this is going to be the last address, and I'm just going to align it so it looks nice. Which is the longest right there. Never use tabs, by the way, for aligning stuff. Only use tabbing for changing scope, because it's gonna fuck with your GitHub stuff. Which, Nick, I'll show you what GitHub is when we're nearly done with the engine. Alright, so now that we've done all this, we have all our addresses down. We could test to see if they're assigned right, but we can see that when it's messing with the heap, to be honest, so we'll ignore that for now. So the only things we have to start assigning first is the screen coordinates. We need to format them to 0 at the beginning. We also have to format the console handle. We have to give the console handle the address before the routine is defined or used, and we also define our first routine. We'll do that while we're doing the routine. So yeah, the return routes we have to set to 0. Yes. So first thing we're gonna do is we're gonna get the screen coordinates, and again, it's a structure, which I'll go more into later. But you have to get the component of a structure, and it does the grabbing of the data for you with the arrow. So you can do the arrow to that component, which is going to be the X, and you have to put data, and it's going to equal 0. And we need to do it for the Y as well, so you're going to put the arrow to the Y. There we go, and it's going to be 0. Now we need to set the console handle. So to set the console handle, Microsoft has a function, which you could find in the documentation that I sent a link to. And that's called getStandardHandle. And we need to provide it the handle we want to get, and that's going to be called the std output handle in all caps with an underscore between each word. It's a macro. And if you look at the P definition for the macro, you can find out what number that handle is in Microsoft's thing, which is going to be the -11. Now that we did that, the last thing we need to do is set the return routes to something, and that's going to be 0. So we're just going to initialize return route to be the value of 0. So data return route equals 0, and we're done with that. Routes. There we go. Perfect. Okay, so now we have all the stuff we need to do this crazy ass routine. The next thing we need to do, let me see how far we are, by the way. 30 minutes. So we're at halftime before we even do the routines. Got it. So we may not be able to do input polling. It depends on how long it takes to make the routine. So to make a routine, it's the same way as making this kind of go-to system. You basically are saying, I want to call a routine here. So it's going to be called the clear console routine. So we're going to say go to clear console. That's what we're going to call the routine. Spelled it wrong. There we go. And you're going to see it's going to give you an error because you haven't defined it yet. And then we want to define a return area. So we're going to do this function, and then we need to find where after the function ends, where we want it to return to. We're going to call it this return, core engine loop clear console return. And you're going to have to put colons there because this is going to be a label to where it's going to come back to. So we have a label to go to the routine and a label to come back. This defines basically the structure of the routine. So now we have to define the routine. So we're going to define the routine right after our setup area, which is right here. So we're going to put clear console. So now this thing knows where to go. And we're going to simply define the return for now as just the go-to right here. But we're going to make it more complicated later, but just for testing. Core engine loop clear console return. So now it knows that it can come to here and then go back to here. But notice that when this thing runs and it's about to hit the core engine loop, it's going to hit clear console. So it's going to do a clear console, then skip the core engine loop, and then go to here. So it's going to start in a really whacked up area. So to avoid it starting a routine early that you don't want to start early, you have to make basically a skip, a way to skip. And the way you do that is you put you basically make it go to like a skip label essentially. So we're going to do skip section core engine loop. And what this is going to do now is it's just going to be a label we're just going to put right down here. And it's going to skip all the routines definition on what that's going to be doing there. So it can do the regular code instead. So now we have the basic structure for now going into the implementation. But so in order to test that it went to the right place, you're just going to put a simple print here. And you're going to be putting here right in there, a little string called here. Just so that we can make sure the flowchart is correct before we actually start going crazy on the code, because it is a nasty routine compared to, I mean, this is the biggest thing you guys have ever made structurally so far. It's been this loop, and this is going to be twice that size. So, yeah. So what we're going to do now is right at clear console routine, we're going to set the 242 as our breakpoint. And from there, we'll just debug it. And it should build. If it doesn't, that means we have to go figure out what went wrong. How did yours go?
It's building.
No problem. Success. So just start it up when you need to. You can hide disassembly. We don't need that right now. We'll use disassembly another time. We don't need it for now. We are going to need our locals, and memory will come in handy, but not now. We're mostly just focusing on the flowchart. So we're just going to see that these locals get an address, a proper address. We don't know if they're the correct address, but we can at least see that it's proper. I mean, it does get one that looks relatively correct. So first thing is console handle got 06. If we look at the last thing, which was delta time, right here, it got FE. So it went from BFE to CO6. So that's relatively, it's probably around the right area. So we'll go to the next one, which is the D word, which is a 0E. So that looks correct.
Is it F11 or F10 to go to the next?
Huh?
Is it F11 or F10 to go to the next line?
Oh, F11 would continue inside. It's the best to use F11 in this case, yeah.
Okay.
F10 does the same thing, except it would, if it was a function, it would skip the inside of the function. So, Yeah, well, for now we'll use F11. So we're at screen coordinates now, so we'll do screen coordinates. It went to C12, so that looks like it's going in order. Console size, CSBI instance was next, and that's C16, that looks alright. C2C, that looks alright. Fill result is C30, that looks correct. Attribute result is C31, and return routes is C32. That definitely seems like it's right next to each other. So when you're ready, you can do the formatting now, and this is when you can actually see where the memory block to see if it actually does anything right. So I'm just going to have a little bit of a peek here. So I'll go to the memory block address. Should have already some stuff formatted. And we're going to see the screen coordinates X and Y get formatted, which is that 0, 0 there. And then the next one is a 0, 0. Good. Then we're going to get the handle. So the console handle should get formatted now. Let's see. It got 0C, which is the correct number. And then...
I think yours is way more.
What do you mean?
Like, it's like you have a lot more zeros. Like, it's bigger. Like more bytes than mine.
No, there's no way it's not the same amount of bytes. That's for sure. I'm trying to see why now. Which zeros are you talking about? Like this thing right here?
Yeah, like literally right here.
Yeah, because I'm seeing that too. It's not as big, you're right. It might be the way we're compiling. You're compiling for 64-bit, right?
Yeah.
It says times 64 up here?
Let's see. Oh, I don't know, it says 86.
That's why. Compile again.
And
Should be nice and fat now.
it's nice and fat now.
We got that thick numbers now. There we go. So yeah, try to go back to your memory block address in the heap and just make sure it formats the screen coordinates right and gets the standard handle, which is going to be 0C or whatever it is. Mine it came out as 000 to C. It did my return route correct. My return route is 0. My screen coordinates are 0, 0. I don't know if they're the right part of the heap yet, but I'm assuming they are. So now we're going to see if our skip works. So you should be on the same line. And if I do my skip, see that it went to that label and then went to the other label because there's no execution there. Went to the next execution line, which is this check here for the conditional. So now if I do the conditional, it keeps going. Now I'm going to do the code to clear console. So that means we're going to do the routine now. So now it's going to do the routine. It's going to print here. If we look, it did print here. So that means it's doing the routine correctly. And now it should go back to where we wanted it to return to. And it did. So at least on my side, I hope your side worked correctly. We have the flow chart. So let's start filling this in with some actual useful shit now. And Nick, you might have to rewind that part because I did go pretty fast through there. So now, in order to make this so that this doesn't just happen on a whim, we're gonna put this inside an if statement, and this is gonna be our first return route. So we're gonna define clear console return core engine loop as 0. So this defines route 0. And next thing, now that we have that route specified, right here we're gonna put an if return routes equal data of return routes, data of return routes equals not 0, the one macro we named, so we can keep contextual reference to what that 0 means. Okay, I think I put an extra. Yeah, I did. What the hell is it doing? That's so weird. Okay. There we go. Now it's behaving. And then I'm going to put this goto inside of there. So right there. And now we'll check. And then what I want to do is I want to name this section right here the clear console return. So this is going to be a generic return I can use during this process that will automatically put it to the return section of the clear console routine. And you'll see why we're going to use that. Because maybe your routine has multiple places. Well, I'll just tell you right now. There's going to be multiple places in here in the routine, for example. They're going to be asking to just go return early in case something went wrong. And that's why we're going to need this generic return. So now we'll get started on the actual routine itself. So the first thing we want to do for the routine to make sure that we actually have something to work with is we're going to do an if statement, and that if statement is going to be basically checking if the return of this function called get console screen buffer info returns the correct value, which is going to be anything larger than 1, I think. I believe, I don't remember completely, but I just know that if it's that if you put it like this, it'll return correctly. And the thing it's going to need is the data of the console handle, which is going to be really the address to the console handle. And it's going to need the CSBI instance where we're going to be storing whatever console screen buffer info that it gets from here. So basically, when you ask for it to get, it's going to store the result as the address for this thing.
Okay.
So basically, if this returns true, that means we do have the screen buffer info which we need in order to do this clear console. Otherwise, it's going to ignore this whole thing and go straight to return. Next thing we're going to do is we're going to get the data of console size and actually set it to something. And we can set it to something by getting the screen buffer information on the size of the X and Y of the buffers. So the way to do that is you can go to CSBI instance and you'll find out it's a struct and it has the size inside of it as a component. And if you do the size and then you do .x, so that's because we have the direct reference to the data here. So that means we can use a dot now instead of an arrow because it's not going to do a get data. So it's going to just have the data for it. So you can put a dot. We can put the x, and we're going to say it's going to be the size is going to be the x, and then we're going to multiply that by CSBI instance. And we're going to get the size again, but this time we want to do a dot for the y component. And again, if you want to see this, the structure of this, because I don't know if we did, you can see other components there. And if, of course, DW size is a coordinate, so that's how you know.
Okay.
So just put a semicolon there. So now we should have the console size, hopefully. From here, now we're going to set the data of fill result as equal to, this is a pretty long thing, so I'm putting a / here so we can make a nice clean version of this. We're going to say the opposite of what returns from fill console output character. And the reason we're doing the opposite of it is because for this function, which you can find out what this macros function is by going to preview like everything else, and you'll see it's fill console character A, which if you preview that is this thing. So now we can see what it needs. It needs our console output, our C character, length, something called that, and something called that, which we're going to fill up now with as soon as I can. So what we're going to do now, I wish this preview didn't cover it. I'm going to have to open it. So we're going to promote this to a document so I can keep a reference to this, because you'll be doing this often. You might need to reference the what something needs in order to use it, which in this case we do. So the first thing is called the console output, and it has a handle, so we can deduce that it's our console handle that it wants. And it wants what looks like a direct reference to it. So we're going to be up to the data. So we're going to be putting, instead of an address, because there's no asterisk here, there's no pointer, so that means there's no address that it wants just the data. Data to console handle. Now we're gonna put a comma here because we need to put a lot more. We need to put the next one, which is called C character. So C character basically means the character attributes. That's what this is. So we're gonna be doing the data for character. Sorry, no, I'm looking at the wrong function on my other screen. My bad. It's going to be the character we're gonna be filling in is this thing. So the character is going to be called a teach character because that's what the console uses, T characters, which again you can look up from peeking what that is. It's some kind of weird thing here. And we're gonna put a literal for a white space character, and then just gonna put another comma after that to put the next data, which is going to be the length. Now the length of this thing is going to be our console size. So we're going to put the data for console size. Okay, so now we'll continue. And the next thing it wants is the D-right coordinates, which is going to be basically our screen coordinates. So what we're going to be putting there, it's basically right here. This is asking for the coordinate of the first cell or the first character to fill of the console. So we're just going to put data for screen coordinates, which are already set to 0, 0. Just like that. I'm just going to align these while I'm doing it, since I know it won't, I hope it won't fuck it up. I mean, actually, I was supposed to put a semicolon here. Now it will, but I can undo it by pressing Control Z, and I shouldn't lose it. Still complaining. Well, that's because we didn't finish it. Okay. So the last thing we need to put is the number of characters written. And that's what it's going to give you. It's going to tell you how many characters it wrote. And we're going to store that in characters written right here. So we're going to put the address to characters written. So we just literally give it instead of going for data, since we're not providing it the direct data. And there's no comma for that one. So after you do that, and you have the semicolon here with the closing parentheses, this stands for one line of execution. We just spread it out. Should be good. So, Hazar, let me know if you're good.
My skip section is I have an error on that. Where do you have yours?
So mine starts here, and it starts right after the console return section right there. So it's right there, and it's before the core engine loop.
I have it, yeah.
Here, let me see. You might be
What's wrong
missing
with
one
it?
thing. Is that a semicolon for the label? No, that's a
No,
colon.
it's a colon.
Yeah, that looks like
I have a semicolon on the go-tos.
Yeah, that's correct. So let me see your skip let me go up to the skip part. Oh, wait. No, it doesn't make sense. Is it called the same exact thing? Skip section?
Copy pasted.
What
Yeah,
the fuck?
copy pasted. Copy pasted. Wait, yours is red too.
It is? Did I fuck
Yeah.
up?
Oh wait, no, you're looking at my screen. Sorry, my bad.
No problem.
I was looking at your screen. Yeah. No, you're good.
It's pointing to the same
Because
thing
you
too.
defined it. Wait a second. No, you.
I did
defined
not define it. I just put the. Is your macro that's fucking up? No.
No, that's. No,
Is your
'cause it's
go-to fucked up? No, it doesn't look like it either.
No, it's always white. It's not red like yours.
Yeah, mine's are weird. I don't know why. I'm looking around. What does the output say? Or your
Output?
errors? What does your errors say?
Oh, I'll try to build it. Okay, skip section was referenced but not defined. The label.
That's weird because yours is
defined
definitely
right
defined.
here.
Your
Skip
go-to is there too, and it's right after. Take out that extra go-to you have. I don't think that's it, but the other one.
Where?
You have one
This
right
one?
below. It's calling to the same thing, but we didn't want to do that because that's not routing right properly. That's not doing it either.
It's right there.
True. I don't know what's going on. I'm looking around. to see if I can understand. It's a colon.
Data.
Finish your characters written. It's showing. I'll comment that out for now. So let's make sure it's not. Oh, what?
Oh my god.
What was it?
It was a parenthesis.
Ah, that would
on
do
the
it.
If statement, on the if statement.
Yeah, yeah, that would do it.
Got it.
Because what happens is the thing you have to consider is that if you get an error anywhere, like right here, for example, anywhere past this, if you get an error before this, for example, it's really annoying, and it could be a syntax error like you just had. It'll stop it from being able to telesense or compile the rest of the code. So you may get an error for like something that's not relevant to it, but it's really something else stopping it from compiling the rest, which would lead to that happening anyway.
Yeah.
Even though that's not it. So you have to kind of take that into account as well, Nick. You're going to have that happen a lot to you because you're not used to the syntax, so just keep that in mind. Yeah, let's if that works, if it's not giving you compilers for that function there, we can continue.
I got other stuff.
Got it. What does it say?
Like, could you build on yours? Is yours no issues?
Let's see. No, you're right. I got some errors.
Okay,
it says
we got the same ones. We got the same
unreferenced label. Yeah, it's because we never referenced the clear console return yet, which we are right now. So let's just do this and it'll work.
Okay,
We might as well just get this over with, then we can see if our stuff is working. So if the data at fill result, because now we're going to check if fill result worked, right? This is the whole point of us storing fill result, the result of this fill console output character, is going to equal true. And if it does, then we're going to return, if it does equal true, we're going to go and leave early because this means it failed. So now we just remembered what the fuck this was. Basically, if this thing returns 0, something went wrong, something like that. So by making it opposite, it would be true. Which in that case, I'm following the Microsoft stuff. I don't exactly like their logic with the way they checked it, but that's what they did. Okay. So I'm just gonna do clear console. Not that. We want clear console return, which is right here. That's what we want to go to. And then now it would figure out, why the fuck are you doing that? Okay, there we go. And then that would figure out to go here, which would then figure out which return route it was specified to go. And there we go.
Got it.
So notice that we're doing this return route, but we never specified to use this return route, right? So it works out here because it's by default 0, but let's say it wasn't by default 0. What you would do, let's say you were in a different position and you had the multiple routes, what you would do is you would get, this is actually a bad name because this is only work up. Change this to clear console return routes.
Okay.
It's a bigger name, but it needs to be, because if you had multiple routines, let's say you were doing a pure imperative program, you would need to keep a return routes for every routine. And Hazel, you probably already know what a routine is at this point because you can see the pattern, but Nick, you're gonna find out after we're finished with inputs. So return routes, we're gonna set the data of this thing to be 0. So we're basically saying, or no, not 0, the macro. So if we go to the macro, yeah, I don't want to set it to 0. I want to avoid that. It's a bad habit. Return to this thing, and then that way it knows before going to do the clear console routine that that's our return route, so that it knows to come back to here. Okay? So that's how you make basically a dynamic routine return without having a dynamic jump function, which C doesn't provide us with because it doesn't. You can't store labels. So, yeah. You can't store labels in this version. If you had GCC, GCC's OP because they realized that people want to use C as an intermediate language, so you might want to do some crazy ass cheats. So GCC has a lot of cheats in C to do a bunch of assembly level bullshit without having to use assembly. But MSVC, Microsoft doesn't like that, so they don't. So, okay, we have everything there. We have the first console return. So we're going to continue this function. So the next thing we're going to do is make sure that you get a not from the... I don't know why they're doing this. Hold on a second. Because I didn't put a comment. Maybe they have a comment. But we're doing basically the same call as we did at the very beginning. So we're doing a clear... Getting the buffer again for CSBI instance. And if we get a not this time... I don't know why. We're going to find out as soon as we look at the documentation. We're going to have to return... So let's find out why the fuck I have to do this. So under the documentation, we are doing this to get the current console's current text attribute. So we need it to return that time. Wait, why are they fucking doing it not here then? The number of current character calls to the buffer. Sorry, I'm having a bunch of bullshit happen to me. Current console screen buffer info. I need to search this up real quick. I don't want to trust them. If the function succeeds, the return value is non-zero, which is what we want. Okay, so basically what's happening right now is before we do the next step, we have to make sure that we get the latest attributes for console handle. And my inference of why we need to do that is this fill console output character might fuck with the console's output attributes. So we need to make sure we were able to get it so that we can, if it has been fucked, we can reset it back to what it needs to be. So stuff you'll be able to make those inferences once you do enough of this cancer. So if you do data attribute results equals, and we're doing the same thing as we did before, we're going to do a not fill console, but now instead of characters, we're going to do attribute of those characters. And from here, we're going to say data of the console handle. Because if let me just do this properly. So we want to find out what this is. We're gonna pick the definition. There it is. But we want to be able to write on our code. So we're gonna promote this to a document, move it below it, and then just make it smaller so we only need to see the parameters for what we want to see. So around this should be big enough. There we go. And now I can keep reference to what I need to put in here for it. So I can do console handle is first. We want the data for it. Then we need the data for the attribute. So we're going to give it the... Is data for attribute? Yeah. So we're going to give it the... Where is it? We're going to be... It's going to get it from the CSBI instance. So we're going to do CSBI instance. And we're going to get the component called W attributes. Put this here for now. And then I want to get the data for the console size because that's what the length is, remember? And then console size here. Next thing is going to be the right coordinates, which again is going to be the 0, 0, which we already set. So we're going to just put the screen coordinates. And lastly, we're going to put the characters written. So we just got to put the address to characters written. And that's all the parameters we need for that. And I'm just going to space out my commas so I can find them easily when I need to. I don't need to put this there, so I can keep that. There we go. Okay, so that's perfect. Now, to make sure that this worked out, we're going to say if the data of attribute result equals true, we're going to, if it equals true, that means it failed. So we're going to go to clear console return. You know what? Fuck their logic. We're gonna fix this because I hate that fact that true means bad. Take out the not in that, and I think that should fix the logic so that we can use a false. And I'm doing it as a design choice. And you're gonna notice it says our false is undefined. We just have to define a macro for it. So if you go to the very top where we put the true, after we put the true, you're gonna define a false, and that's going to be equal to 0. And or defined as 0, not equal because of the macro definition. And now we can use false. And once you've done all that, the last thing we have to do is set the console position because we just filled all this shit up. But we never... What the fuck happened to my spacing? When did that get fucked? Damn it, me. How does that... How did anything I do fuck that up? Hold on, I just want to see where the... Okay. I'll fix it later. So the last thing we have to do is set our cursor back to the origin, or original position. So that's going to be screen coordinates. So the way to do this is what we're going to do is we're going to set console cursor position. So cursor position right there, that one. And we need to give it the console output handle. So we're going to say data to console handle. And the data to the screen coordinates we want to set the position to, which is going to be the ones we've been using this entire time. So now that we've done that, essentially everything's been successfully done, so now I can properly return. So all these other places were fail cases, fail areas to fail at. This is finally when it can return properly. So I'm just going to put here successfully cleared, returning to original routine, which means it's just going to exit and go to the next line for the return. So now this is, keep in mind, this was all just to clear console. Imagine how bad it is to fucking refresh a screen in OpenGL.
I need some water.
That was a pretty bad one, I know. Okay. Thankfully, they do have a refresh function, but have mercy on the souls who had to write that. And it's usually auto-called for you by the drivers and stuff. We just made an hour, so can't do input this time, but we can test it. So when you're ready, Hazar.
Let me see if it builds.
There is one thing I'll do as a bonus if you want
Builds.
to, because you're gonna get pretty disappointed after we do this because of something. And it's actually a good thing, but at the same time it's a bad thing because it's gonna be like a turn off when we run at runtime. So put your breakpoint at right here, I guess, so that we can just see that the flowchart for everything works. So just right there.
Core engine loop.
Right up.
Oh,
No, no.
before-
Right. Sorry, but I've
Oh,
changed
wait.
it. Yeah.
Right before clear console. Where's that shit at? Here it is.
So right at like 272, 269 is also good. Anything there.
Wait a second. Where the fuck is clear console?
You defined that macro, right? The
Oh,
clear
here it
console
is.
return. Yeah, just put it right
Got
there.
it.
No,
Got it.
right at the go-to. At the go-to. We want to make sure the skip works. Yeah, right there. We're just making sure because we put a lot of shit around that area, so we're just making sure. So I'm gonna close this. Gonna save. I'm gonna build. Can you build?
Yeah.
Okay, we're good to go.
Oh,
So
Didn't succeed.
didn't succeed.
But yeah, it just says up to date. What the fuck does that mean?
Oh, just clear. If you want to make sure, just do a rebuild.
Clear solution.
Rebuild clear is also good.
Clean and build.
Yeah, we're good to
succeeded.
go.
We're good, yeah.
All right. So if you press local Windows debugger, we can now check to see if this routine works. And what we're gonna do actually, before we actually run this, I forgot to do this. Let's put a deallocate right after clear console return is called right here in our engine loop. And the reason why is because we want to make sure we don't have any heap corruption because we made a bunch of addressing,
Yeah, we did.
but we never checked if there was a heap corruption or not. So we're going to check that by doing that without having to actually exit the loop. We're going to delete it after we're done with the heap check, but this way we can get 2 birds done in 1 stone. We can check if the execution is in the correct order, and we're also going to check if our heap got corrupted or not. So as soon as I'm done aligning this, because I want to, I'll build and we can test it. So let's run our local Windows debugger. So we already know the address is going to be. So you can just do that, do that. Okay, so the skip worked perfectly. We're at the core engine loop for mine. I just want to make sure yours shows the same thing once you're ready. So just go by each one by one. Oh, just press continue. You accidentally still had that breakpoint too. Just press continue. Or that too. That works too.
Okay.
And then if you press F11 again, you should skip it. You did.
All right.
So now we're gonna go in here. It's gonna do the loop time seconds. We can check that in our console. It's correct. Now we're gonna go to clear console return routes. We're gonna set the return route to 0. It should have set it to 0. In this case, it ignored it because it was already set to 0, but that was just because we wanted to show the proper way of making sure it preemptively was routed right. Now we're going to go to our clear console routine.
And we're here.
Yep. Now the first thing we're going to do is check if we can get the buffer info. We could. Nice. So now we can get the console size. We did. That's the full console resolution and area. Now we can do the fill results. We're going to try filling. It filled. So that will go through.
The result is true.
Yep, which means it went through. Because we changed their logic, because fuck that. That didn't make sense to me.
Yeah.
It got the screen buffer info, so we're good. We were able to fill the console's output attributes for all the stuff we just filled in. So that means that worked. Now we're going to set the cursor. So now if you look, our cursor is a little bit fucked up. If you go to your console,
Wait a second.
you can alt-tab.
You said that's a true.
Yeah.
I what's it called?
No. I have it false. I have it equal to false. Where?
I don't see it. In
Attribute
data,
result. Attribute
data
result.
attribute.
Yeah, data attribute result can be.
See, you don't. Your fill console output attribute.
Yeah, I changed it because that was their logic. For some reason, they wanted to use true instead of false.
Yeah, I messed that up.
Just put a breakpoint there. Just put a breakpoint there and go back to it, since we already know everything else is correct.
Alright. Let me take this one off. Alright.
Yeah, and you just get to there and you're good. Oh, you gotta press continue. You'll be good after you press continue. No, just press continue. It's right there. Okay, so now we're back to normal. So now, if you it's false, right? Should be attribute result.
Yes, it was false.
Okay,
yes.
so now if you look at your console, you notice your cursor's down there on yours as well. So this is what set console cursor position is going to do now. So now if you press F11 once and then check your console again, your cursor should be back up at the top.
see. It
And that's
is,
how
yeah.
you know.
Top left, yeah.
So now our clear console routine completed. It completely cleared console for us. So now it's going to go back to the return. So now it's going to check which route we wanted to go through. The first check is going to be to the core engine loop, which is our only route that we defined so far for this clear console return. So now if we do that, we can go to clear console return, and we're back to our area where the deallocation is going to happen. So I'll let you do it. So now we're going to go to the clear console return, and if you had to deallocate there, we could take the deallocate. So, but you did, it worked for you essentially. I'm going to check,
Oh crap.
yeah, just add the deallocate to your
Yeah,
thing.
my deallocate is outside, so it's not gonna do it.
Yeah, just add it down there. Just right below it. Just add a, copy and paste it, yeah. No, keep it. We're going to need that there for when we add the input later on. After the return, because that's where your code's going to continue after the routine. Okay, so now just put a breakpoint there, remove all the other breakpoints, and then get to backward to where you were. And we're going to see if any heap corruption happened. So just press continue. Press continue. And now press deallocate. And if it properly deallocated, if we go back to the memory block, it should have been filled with one character, and that's going to be this little Y-ass thing, which is going to be basically called DD. So if you look at your memory heap, you'll see it all get filled with DD, and it looks like we had no heap corruption because it didn't throw us an error. Or at least on my side, I didn't. So if yours didn't, you need to go to debug, Windows, memory, and you're going to click on memory 1. There you go. And now you just go to the memory block address, and you'll see that's all filled with DD.
Memory block. How do I go to it?
Double click the address. Yep. That's it. No. Double click and copy.
Double click.
Control C. Or that. Paste or Control V. Wait, what?
Oh, that's nice.
What?
It copied like everything.
No. Just copy the. Oh, okay, that works too. Yeah, just do that. It's kind of weird that it did that. And you'll see it's all DD.
Oh yeah, I see the Y's.
So that's how you know. Okay. So our clear console routine works. So now, if you remove all your breakpoints, remove that deallocate, remove all your breakpoints, you should, if you run it, see something that's a little bit unfortunate. Kind of sad to see. So run it.
Wait, where do I remove the deallocate?
Just delete it. You don't need it anymore. We already made sure there was no heap corruption. So now run it.
Should I delete all of them?
No, we're going to be
Oh,
using
just-
that one. That's the exit of the app, but we haven't been able to get there yet because we don't have an
Got it.
input check.
Alright,
So now if you run it,
Wait, you said
take
remove the breakpoints, right?
yeah. And up there too. There's one there. There you go. Now, if you run it, you'll notice something.
Uh-huh.
It's clearing faster than your screen can refresh.
Oh.
So, it's actually performing really well.
Yeah,
If
it
you
was just like-
resize it, you might be able to see your loop time every once in a while.
Oof, it's too fast.
Yeah, so
Not even once it shows me. I see it on yours.
there is a way to get this thing back, and that is by
Oh,
making sure that it only clears the console every time the screen refreshes or is going to refresh around that time, or a little bit longer than that. So do you want to implement that now, or do you want to wait till next session? I'll give you the choice.
implement what now?
We're going to implement a way to make sure that clear console only happens after at least one screen refresh has happened. It's not as much code as you think.
Well, yeah, let's do it.
Okay. So to do this, we have to start adding some stuff. We have to add some stuff to our... I'm looking at what code I added. Hold on. we need to add a console refresh timer and a console refresh interval. So there's going to be two addresses, and they are going to be float EPs. So under your timing, because even though it's part of the console, it's not part of routine console. It's part of the timing, really, because it's going to be part of our render refresh, to be honest. But for now, we're going to be calling it the console refresh. So we can say under timing, console timing, okay? So console timing right here. And what we're going to be putting here is an address again to a float EP. And we're going to call this one the console refresh timer. And address to float EP console refresh interval. Okay, so console refresh timer's address, it's going to be after the address of delta time. Notice it's going to affect our other stuff, but we'll fix that in a moment. So that's going to be address of delta time. So I'm going to say this is going to be casted to an EP. And we're going to put delta time plus 1. And I fucking misspelled it probably. That's why it's giving me shit. Yeah.
Oh, this is gonna be nice.
And then we're
Just
going to...
realized.
Console refresh interval is going to be address of float EP. And we're going to put console refresh... Oh, I put the fucking same name. There we go. Console refresh timer plus 1. So, you'll notice it's fucked up. It fucked up our last one, but it's not actually that bad because all we have to do is really change one thing because of the way this stack structure works. So we gotta just get this thing right here, and we just gotta replace delta time here with that, but all our other references are straight because they're referencing the last one.
Oh, that makes things nice.
Yeah. Well, this is we're making a stack. Well, what we did was we manually made a stack, but I'll go over what a stack is later. It's an ease of use thing, Nick. Hazar knows what it is. That's why I keep saying it. It's eventually you're gonna see how much easier it makes your life, Nick, once we actually start using it, because it'll make it so that you don't have to use pointers all the time, essentially. When you know the size of things. So. Yeah, we have the interval and refresh timer set up. We gotta set the memory for them though. So up here in the size of time data, add 2 more float EPs. So we have 1 already here, so just make it multiplied by 3 because we're adding just 2 more to that. And that should right up here in Sims tie data. Just add 2 more float EPs, so multiply it by 3 to do that.
Oh, for time data.
Because you'll notice it's part of the same sector that we organized.
I was still on just times 3. I didn't add multiply the uint.
Wait, what? Uint?
Go back up there.
I'm looking at yours.
Oh, yeah.
Oh, you gotta add the
the
N64. Where?
Exactly.
Wait, you didn't have that?
No, I didn't.
Oh, wait, how did your shit work then? And it didn't give you a heap.
No,
What?
it worked.
And you had the size of... You had it N64 defined.
Yeah, I did.
The fuck? Wait, where's your... That means your loop time elapsed. You had a loop time elapsed though, right?
Yeah, of course. Wait.
Oh, you gotta fix that. Go up. Go up. You didn't put size of, you put size. On your N64.
Oh, there it is. Thanks.
If you go back down to your timing section... This is bothering me now. Like, what the fuck? How the hell did you get away with that? Your loop time elapsed is there, and you gave loop time elapsed an address, and it... Okay, console. I mean, program, whatever. All right. Well, we just fixed it, so there we go.
All right. Cool.
Let's keep going. That bothers me so much. All right. So we just want to make sure that no matter what, this is going to work. So we're going to first set the data of the refresh timer to, we're going to use 0. So we're going to set 0.0 at the beginning. Now for our interval, to make sure that this works no matter what, we're going to set it way above our refresh rate. So this is going to be based off delta time, basically. So this is going to be adding up. The timer is going to be basically keeping track of a bunch of added delta times, okay? So the way to figure out is find your console's, your screen's refresh rate in this case. So mine's, it refreshes 144 hertz, which is 144 times per second. So I can do 1 divided by 144 to get the decimal. So it's going to be this much. So I want to make sure it's bigger than this. So I'm going to be making it 0.009. It's going to be a little bit slower, but just fast enough. I mean, just enough that it still refreshes pretty fast. And it's not going to be perfectly accurate. So what's going to happen is there's going to be a flicker that occurs, but I don't mind because this is just for testing.
Wait. So I want it to be like lower than it?
You want it to be bigger than this. Bigger than your refresh rate. Whatever your monitor's refresh rate is, you want it to be bigger in this case.
So
You would
in
want
my
it to
case,
be exact, but exact
0.0
doesn't always work out, so you might want to have it a little bit bigger than that. Or else it might...
I got 0.016. Should I do like
0,
0.02?
007. It's 1 over 60 that you got?
No, 0.16. 1 over 60, yeah.
Oh, do 0.02. Yeah, you're right. 0.02. And then, in order to implement this so that we can make it work, is first thing we do is we need to make the math for it. So right here, after our delta time, we're gonna do the data, and we're gonna do console refresh timer, and we're gonna do it equal to data console refresh timer plus data. And the reason I'm doing this is because I haven't shown them the shorthand ease of use operations. That's why we keep doing the self-reference. Data cycle, not cycle, that's an extra thing for later. Delta time. I'm just gonna align these. Okay. So we just did all that. So we have this now. And now to make sure that this thing doesn't happen all the time, we're going to do a check here. So if the data of console refresh timer is greater than or equal to the data of console refresh interval, then it can do a console refresh. And only then. So I'm going to put this stuff inside of here. And then after the go-to happens and it returns, we're going to do something else. So let's say after this entire thing happens, I don't know why I didn't paste both. That was dumb of me. We're going to do something here. So we're going to... this is technically a render in our case. So we're going to put the render in here. So we're going to render after a clear happens. And after that, we're going to reset the data timer because we want to make sure we have a 0 to start off with so that it basically starts counting. You're going to see if it's reached the interval. So we're going to say data of console refresh timer equals 0.0 again. Okay? And now with all of that, if you press build now, you should see your delta time get updated with a flicker. And mine's still fucked. I probably made it too high. It's probably still not good enough. Maybe if I make the screen smaller, sometimes that works. Nah, it's still too much. I'm gonna increase my interval to like 1 second. I'll just make it update. Oh, 0.5 seconds. That will force it. If it's 0.45 seconds, I think it'll make it work no matter what. That's more than 0.5 seconds. How small is my delta? Oh, that still doesn't make sense. 0.5 is doing that much? Jesus. All I did was add to it. Is my delta time like a 0 for this thing? Okay, let's try 0.05. Is it reaching that? Oh, it refreshed. Did I fuck up my logic? Trying to see what I did wrong. Hold on. That's correct. Go to Clear Console. Print F, loop time in seconds. And I print out delta. That is correct. Data console timer equals 0. I have to do that. I said the data equals that thing. I can use delta time. I don't think that's a problem. That's really bothering me now. What about 0.1? See if it works for you. I want to see if it's just me.
I still need the line to print.
Because for some reason it's showing me it's not clearing. Oh, it does. There we go. It does, but it's fucking... Oh, there it is. I don't know why it was so weird. But there it is. You see it, right? On my screen?
I see it.
See if yours works to some extent.
Wait,
Once you
can
get
I
it.
see your go down?
Yeah, no problem.
There.
As you can see, that delta time is disgustingly small.
Data.
Notice our program is also going to be like less than a megabyte in size. I didn't even think about that. That's right. All our allocations have been that small.
I think we're good.
Yeah, just press run on that. See what happens. Okay, you might have to shrink your console.
Oh.
Oh no. You're not clearing. Something's wrong. You're ignoring the clear. Did you delete the printf? Stop it. Did you delete the extra printf? You didn't. That's why.
Oh, let's get rid of this one.
Yeah, because now we're putting it properly in its place, which is going to be the update render area.
Okay.
So now try running that now, and hopefully you only see it in one line. So it's doing hello world. Press the right click it, because that's what helped me make it work. Right clicking doesn't do shit. Try resizing the screen. It's not updating it. It's not clear. Oh, it cleared console once. Wait, it cleared console once. Right click it. It's not showing it. Stop it. Go to... Just stop it. I don't know what it's doing. Go to your interval and increase it.
Interval.
Up there. All the way to the... yeah. Increase it to like 0.1 is what I did. There is a way to make it more accurate. In my... when I was doing my mock version before this, I used microsecond cycler
How
to
come
keep
it
track
takes
of...
so long to get rid of this though?
That's what's bothering me. I don't know why. I have no idea why. Right click it? I don't get it. Because that means the reason it's taking so long is it never... We're using greater than or equal to, right? It's not... you didn't use equal to, right? You used greater than or equal to?
I'm pretty sure I did greater than or equal to. Let me see.
Because if you didn't, I would explain it.
I did right here.
Okay. Maybe delta time's just not good for that. I'm trying to see why.
I'll
Because
put
what I
less instead of more.
you put less,
I'm gonna try.
less than or equal to the no, because it's gonna do it constantly. Think about it. The whole point is that it reaches the threshold. The threshold is the interval. You get it?
I don't. But that's why I'm just trying everything.
Okay, so what we're doing is basically this is gonna be looping, right? And every time it loops, you get a delta, right? Of how long the loop took to take. The amount of time it took for the loop to take. What happens is every time you complete a loop and you keep adding it, it keeps adding it to the refresh timer how many deltas you've done. Now what you're doing is with the interval, you're comparing that added summation delta with the interval of time before you do another refresh. So how much time do you want to wait before you decide to do another render? You get it? So in this case, if you put 0.1, it should take 0.1 seconds before you decide that the timer has taken enough deltas to do another render.
I did less. And it worked.
What? And it
Look.
worked? Yeah, but that's not showing you it. That's the problem. So it didn't work.
Oh, you mean like I should see the loop time? That's right.
Yeah. So mine's wrong too right now because it's not doing shit. I'm gonna breakpoint this. I want to see what the fuck is happening here.
Yeah, this is.
Well, now it's just not updating. If I put it less than, it's just not gonna update. If I do greater than, and then I press the local Windows debug, and then I have it loop, it's gonna happen every time because there's no way it's not gonna have enough delta because I'm doing it so slow. Because it counts the delta of you pausing it per execution. It does count that. So you can only test this in real time. But then for some reason here, the delta, for some reason in this case, which I'm gonna breakpoint this right fucking here. I want to see the time. What was the time on this shit? My delta time was 0.259. And my fucking where's the refresh timer? The refresh timer is 0. Console refresh interval is fucking 0.1. And my timer is fucking 0. Are you actually refreshing?
Are you refreshing?
Oh, this is so annoying. Hold on a second. What the fuck is this?
That's a good question.
Look, it finally refreshed, but it's not showing me shit.
Yeah, that's
If I do this, if I shrink it, it shows the refresh.
That seems like a fucking.
So
19.
just to show you that I did get this to work before, I'll show you the uncommented version working. This is how mine looks like. Yeah. What you don't have that I have, other than the cycle count thing, because now I'm kind of pissed off. Why the fuck is this not working? Because the thing is, it should work with delta time, right? Because we're using a float extended precision. Is the only thing I can think of is that associativity doesn't hold the floating points, but I mean, like, I thought, don't float. Can you check for this for me? Does floating point extended precision have an accuracy of? I thought it had an accuracy of like 6 to 19 places or something like that. I'm pretty damn sure it had.
Yeah, it was around there. Let me check.
It's like 16. Okay. What? It's about 20 digits on extended precision. That's insanely accurate. And the delta is also that accurate. Both the delta time and the refresh interval are that high. They're not small things. In fact, let's change loop. I'm going to change this loop time to be delta time. That's what it is. And I'm trying to see what to do here. I don't get it.
Well, if that's the case, I say we
Call it?
Yeah, we call it, and then for the next time we at least it's figured out.
Yeah, because worst case scenario, you're gonna have to do it the way I did it before. But what's I can show you. Let me show you the way I did it before, because it's not that much more core difference. So the way I did it before, this is the uncommented version. Let me include it in the project so you can actually see the syntax highlighting. Gotta exclude this so I don't get errors. So if you look at this thing here, I have this thing called a cycle micro interval. Okay? And what cycle micro interval does is instead of using the instead of going directly to the delta, I kind of changed this up a little bit. So in execution, I was gonna do this later. I didn't know. I wanted to try the delta with you because I thought this would be better because I thought this was a little bit excessive. So here we just did it to loop time elapsed. The problem is we lose the information of this being in pure ticks, which is what I didn't like. So the reason I did this is so that I can retain the loop time elapsed in ticks, and then I can also keep a separate thing that keeps track of the ticks in microseconds, which I then convert straight to delta afterwards. So what I was doing here was I was using the console refresh timer with the cycle micro interval instead of the delta. So before this division took place. But that shouldn't affect things, in my opinion. So my interval, I could make this big and it would work no problem. Everything else was the same, keep in mind. It's just that the interval now is huge because we're dealing with microseconds, micro intervals instead of seconds. But here's the thing. It still flashes out, but that's because this is a huge problem. This is because you don't have a fixed time rate yet. I don't even know if you can. I'm pretty sure we can get pretty close. Again, we're trying to deal with a shoddy text render. We haven't made a proper text render buffer. This is before that. So you'll experience this flicker, but we can read stuff and it's updating nicely. And if you make it big enough, which is good enough for testing, to be honest. So let's say I made this like 50 in my version. You can see it's more stable.
Way more stable.
And yeah, it's just how much slower do you want it to be versus flicker. So it's just an old-fashioned, just a really off the way of doing it because we're not using OpenGL. But it kind of shows how much work has to go into making sure the video buffer doesn't flicker for you. By making sure with your variable refresh rate, you're still syncing up with the refresh time of the monitor and all that stuff. And how they do repeat frames and stuff like that. That's why it's important, because otherwise you get this bullshit. But yeah, unfortunately I wasn't able to get it to work with Delta. I don't know why. I'll work on it sometime when I have the chance before Monday. But yeah, it's kind of weird that it doesn't behave. Alright, that's stopping it from there. How was that?
Oof, that was thick.